The Apple of your EFI, an analysis of state of Apple's EFI security supports. Rich Smith Pepijn Bruienne. 18. The Apple of your EFI, an analysis.
Okay.
The Apple of your EFI, an analysis of this.
Hello, it's fantastic to be here. Can we get the slides on the main screen? Perfect. So, yeah, we've actually made it to Buenos Aires. This has been on our list for a very, very long time, so we're very pleased to be here. Very happy to share our work with you today. We released the paper, so it's been a long time in coming, but we're happy to be here. So, who are we?
Hey everyone, my name is Pepijn Bruienne. I'm an R&D engineer with Duo Labs specifically. Only been doing this for a little while, so bear with me. I am, however, a recovering Mac admin, which means I manage lots of Macs in large organizations, so yeah, the pain is real. I also maintain a couple of open source tools that are used a bit, and this kind of, my position at Duo kind of flowed from breaking things in that world and wanting to do that full time for some crazy reason, so that's why I'm here.
And me, I'm Rich Smith. I'm Director of R&D at Duo Labs. I've quite the opposite. I've worked in security for all my life, probably far too long by now. A lot of my time I spend looking at research at scale, trying to look at things at kind of internet scale. Also enjoy a lot of post-exploitation stuff, a lot of post-exploitation framework development. Obviously, I enjoy firmware, and that's what we're talking about today. And I like to play around with Python a lot as well. Quickly about Duo. Like I say, we're from Duo Labs, so we get the nice opportunity to not make any profit for the company and just spend all the money. And we like to break things, we like to build things. We release prototypes, we release as much of our stuff as open source as we can, and obviously we develop new products for Duo. That's why they let us hang around. And as it says at the bottom, like everybody else here, we're hiring. So, there's quite a bit to cover today. But we just wanted to give you the overview of things before we start to dive into any detail, so you could kind of have things in a framework and know where we were going. So this whole research really began when we wanted to shine a light into an area of the system that we thought was pretty murky, people didn't have a good understanding of, and this is around firmware security, in particular EFI. And we really wanted to balance this to understand how well EFI security was being serviced as compared to software security. So everyone's heard that you should patch all the time. What's the situation with firmware? Is it equitable with the software security support which is being given? To answer these questions, we analyzed a huge number of updates from Apple, all of their OS updates, all of their security updates, and all firmware updates that were released within those for 10.10, 10.11, and 10.12. It's about 3 years worth of data that we analyzed. We then also went further. Pepijn pulled in all of his friends, and we got 73,000 systems that were real-world systems running Macs, so we could have a comparative analysis to the data that we'd pulled directly from the OS updates compared to real-world systems to see how the real world was matching up against an idealized world. And we compared these data sets, and a lot of what we're discussing is the findings between those two data sets. We also have a lot of information that we pulled directly from the analysis of what Apple released themselves. We found a bunch of anomalies in there. So we're going to dig into all of that. But one big question before we go forward, like, why Apple? Why did we choose Apple and not Windows? Well, quite honestly, it's because we're lazy researchers. It's much easier for us to analyze the Apple data set because they control the whole stack. They control the hardware, the firmware, the OS, and the applications. And the way in which the EFI updates are bundled within the OS updates allows us to create a really good data set so we can do this comparative analysis. We'll come into the details of that in a few slides' time, but our intention is absolutely not to bash Apple. Quite the opposite. We feel that they have some of the best EFI security in the world today. They're taking it very seriously, and their firmware security team is world-class. So, quick overview of what we're going to do. Going to jump into EFI 101. We realize not everybody knows what EFI is. We're going to do a very quick overview of that. We're going to do a quick run through other researchers' work in EFI. You know, we're standing on the shoulders of giants here. People have done some fantastic work, and we're going to give you a quick overview on that so you can go and dig into that more yourself on your own time. We're going to explain how Apple Macs update their firmware, and then we're going to dig into the new work, what we did, what we found, and then what we're releasing. There's only so much that we can go into in a 50-minute talk. We've released a paper. It goes into far more technical depth than we're able to in this talk. That's the URL. Grab it. It contains all the data. There's tables and tables of data. So get stuck in. There'll be this link at the end of the talk as well, so you don't have to remember it. So Pepijn.
All right, so this whole EFI, UEFI thing may be familiar to some folks, maybe not everyone. We definitely learned way more about it than probably we would ever want to know. So we'll do a real quick overview. This is in no way meant to be technically exhaustive. It's by design not exhaustive. So what is this thing? Just the other day, I was trying to explain this to someone non-technical, and I figured, think of it as a starter motor in your car. When you turn the key, the engine doesn't turn over by itself. It actually is a starter motor that does the kicking in. So think of it as that way. It is the thing that makes your computer do what it does in all the following steps by actually initializing all the very low-level pieces of hardware that it needs to actually do a job. So it goes from power on to loading the bootloader, the kernel, and then finally the OS, where you get to have your fun. A replacement for the BIOS. I'm sure someone in here owns a computer that probably still uses BIOS for something. It's been slow to sort of move out in other platforms than Apple. There's a lot of legacy based on that. But IBM BIOS was popular, but it's from the mid 1970s. So quick math. 40 years later, we probably should be moving on to something else. And it is everywhere. So Intel worked on their own on EFI starting in the mid 90s. Then around 2005, the UEFI standard was established, which is where Intel folded their earlier EFI work into it. And Apple themselves started using EFI in 2006. So Intel EFI, developed mid-90s. They wanted to get rid of BIOS. They had a number of restrictions that they wanted to get past, 16-bit, limited memory, all the stuff that BIOS is terrible for. And they worked on until about version 110, and then decided that it would probably be better if they joined in a larger consortium and had other vendors work on it with them. So they formed the UEFI forum. EFI, by the way, we say kind of both. In the rest of this talk, we'll kind of just use EFI because that's what Apple uses, in case you're wondering why we don't call it UEFI. It's universal. There's really the standard that Apple goes with. So 2005 UEFI forum founded, and they had a couple of clear goals. So they needed to be boot from large GPT disks, larger than 2 terabyte. CPU independent architecture, all that, flexible pre-OS environment, modular design, before backward compatible, pretty much anything you would expect from a regular OS as well. They wanted sort of the same thing out of that pre-boot environment as well. Vendors joined, and Apple as well joined that. So Apple killed off EFI when they switched to Intel from PowerPC. Prior to that, they used open firmware that came out of IBM. They got rid of that. They added some base compatibility for the boot camp functionality where you can boot Windows on a Mac. They stayed on 32-bit EFI for quite some time, actually longer than probably should have, even on 64-bit Mac. So through 10.4 through OS 10, 10.4, 10.7, they were 32. They switched. 10.8 started with full 64-bit support, and it sort of has the same functionality. It needs to support new Mac hardware, new features, and needs to stay up to date. And then there's some platform-specific things that it needs to support, like NetBoot, which is when you start up a Mac, you hold down N, it will look for a net, very similar to Pixie booting essentially. And Internet Restore, which is where you hold down yet another key combination, and will actually reach out to Apple servers, boot from an internet-based image, and give you the ability to reload a Mac without having local storage to do that. And like any other EFI and any other firmware, it's mostly invisible to end users.
So, if that's EFI, who is it that actually wants to attack EFI? It's a very low-level part of the system. It's not necessarily the easiest attack to develop for. Sometimes needs physical access. So it tends to be actually cared about by well-funded adversaries. So you'll hear this talked about for things like nation states. You hear that a lot in the media when people are hyping stuff up. Industrial espionage. This is not a script kiddie tool. We don't expect to see this kind of attackware being used in kind of like mass market indiscriminate attacks. So it's good to keep in mind that this is very much part of a sophisticated adversary's tool set. So what makes it interesting to a sophisticated adversary? Why do people put all of this effort in? There's kind of three main reasons to keep in your head when you're thinking about EFI security and why it's like a good thing for the attacker. One, it's very stealthy. It's really hard to detect if EFI is compromised. I know there's Alex in the audience who is working hard on making this first point untrue, so that's great, working on actually detecting firmware attacks. Persistence is also key to EFI, or EFI attacks. Once you've got your attack code into the EFI flash ROM, reinstalling the OS, removing the hard disk, doesn't actually remove the attacker from the system because they're in a completely different part of the computer itself. Their attack code is running out of a flash ROM, not on the hard disk. And the very low-level nature of EFI, people will talk about it running at ring -2. So if you know the Intel protection rings, ring 0 being the OS, ring 3 being application layer, there's kind of two made-up rings that people talk about. Intel never kind of published these, but in future years they've come about. Ring -1 is termed where the hypervisor sits. So the hypervisor sits below the OS. Ring -2, EFI, SMBIOS, some other things, this sits even below the hypervisor. So if you manage to compromise that EFI, you have some very low-level access to the system. You can be reading, writing to arbitrary places in memory and disk, some little caveats there, but the takeaway being it's a very, very low-level part of the system, and you can circumvent many of the security controls at higher levels in the system, whether that's hypervisor, OS, or application. From an attacker's perspective, this is a very attractive place to sit within a system. So we're going to do kind of a whistle-stop tour of Apple EFI security, some of the things that people have done before us. All of this research, please kind of go dig into on the internet. You'll find a lot of good examples. Snare's work from back in 2012, presented at Black Hat. This was some fantastic work. Really, some of the first public out there work showing the ability of kind of using the Thunderbolt path to actually inject code into an EFI. Sonic Screwdriver, which has been much more recently spoken about as part of some of the WikiLeaks Vault 7 leaks, is really a weaponized version of what Snare spoke about. So even though it's only come to light recently, and apparently it's from the CIA, I've got no idea whether it is or isn't, but we'll assume that it is, and apparently it was based on Snare's work, so we'll assume that it is. Again, this was a physical attack, required a Thunderbolt adapter to be inserted into the device to actually compromise the EFI. Thunderstrike 1. Trammell Hudson at CCC 31, fantastic work. Again, really stepping up the complexity with which and the elegance of the EFI attack itself. Again, modified adapters. This required physical access to the system, something to be plugged into the device to compromise its EFI. Thunderstrike 2, however, shit got real. This doesn't require anything to be plugged into the device. This is a software-based attack. Obviously, that line of people at the top, Trammell Hudson, Zeno Kova, and Corey Kallenberg, excellent excellent research in EFI and firmware and embedded attacks in general. Definitely look at their talks. Thunderstrike 2 is an incredibly elegant attack. Ulf Frisk, more recently last year, spoke about some of his DMA attack work, PCI Leech being the name that he gave to some of his tool sets. And he demonstrated that operating at that very low-level part of the system allowed him to actually extract encryption keys, 502 encryption keys from the hard disk because he was operating at such a low level. This was an interesting one in terms of Apple's response because it really kind of stepped up. They ended up releasing a lot of EFI patches to address this. This is most likely because it was a software-based attack, not a firmware, not a physical attack that you needed to plug something in. So this one definitely steps up the game. Pedro has also done some excellent work. Please check out his work in the space of EFI. And all of these people are doing amazing work, so we definitely encourage you to kind of read up on it. So, the firmware updates.
Let's talk a little bit about how Apple solved updating this stuff. Now that we've learned that it's fairly important and fairly devastating if you can get access to it. So we'll look at how the historical way Apple did it and how they're doing it now, and kind of how they were prompted into improving the process, and also some new additions they made in 10.13. Most of our research stopped right as 10.13 came out, but we obviously did some looking ahead research during the beta period, and now that it's out, we can actually talk about it without getting into trouble. I don't know, maybe. So how does this all work prior to 2015, which was kind of the watershed moment when Thunderstrike 2 came out and it was no longer, Happy Valley. So this was a very, very manual process. So the user needed to go to the Apple website, download an application, run it, follow very specific instructions, shut down your Mac, hold down the power button, wait for a beep, now let it update and don't touch anything. So yeah, what year is it? We need to do this better because no one is going to do this. And if you're in a large environment and you have to do this to, I don't know, you're a Google and you have tens of thousands of Macs out there, both locally and with users in the field, this does not scale at all. So mostly it was no big deal. We'll just skip it. Who cares about EFI anyway? It's probably safe. Yeah, so probably not, as it turned out, because Thunderstrike showed that it was, even with a drive-by, or rather with a evil May type attack where you need physical access, it ups the threat model significantly. So Apple decided to change this, to their credit, and they now ship EFI updates as part of OS and security updates. So if you look at a security update or OS update, you'll see a part that says firmware update. It is a package like every other software that's distributed on the Mac, and it runs its own tool and essentially sets up through EFI update, which is a binary on every Mac, and it invokes it in a specific way to invoke a EFI update if needed. It uses the EFI system partition, or ESP, which is a part of the EFI standard as well, to make sure that the current version is persisted. And this is we're just kind of listing how this works here. So every OS update ships with a complete set of current EFI for all models that they support, and we'll go into what support means in a later step. So this streamlines it into what people know much better, which is, update your stuff, update your Mac, update your computer, because, dragons out there. So this worked in principle a lot better because this scales much better if you need to do thousands of these guys. And if you like small type, I included some, but this is the output when you run EFI Updater by yourself. You kind of see what it does. So it looks for system partition and it goes through the steps. Ultimately, uses the bless function, the bless application to say now boot from this particular EFI binary, which kicks off the actual update. So that was a lot better than what it used to be. This is part, like I said, it's called firmware update.pkg. It is always all-inclusive for current OS versions. What that means is that when you step back, and we'll have some more on this in a bit, the actual support for EFI versions and models kind of steps off. It slides back very quickly, which they will actually ship. So that is another reason why you want to be on the latest OS, at all times, if at all possible. If the update fails, the EFI update specifically, EFI update does not get another chance to run. So it's kind of a one-shot deal. So it either works or it doesn't, and then it moves on. It is silent about it. There's the question of how does this utility figure out which EFI update to include for which machine, because there's obviously lots of Macs out there. They all have slightly different configuration, different revisions, etc. Apple uses something called board IDs, which is the most specific identifier you can get out there. So we had some questions. Does every model have its own payload? Do you have hundreds of EFI files, or is it more contained in some way? And how does the updater know this? So I dug into that a little bit and figured out how Apple identifies these. So the more well-known ones are like the model number, major version, comma, minor version. You'll see this around, like if you go to a Geekbench, you'll see these listed quite often. But these are not specific enough. They cover more models. They cover more models than individually Apple knows about. So they use something called board IDs, and you see that below there. So they use a MAC dash and then a 16-digit hex string that is the unique identifier for that specific board. So how does the firmware updater know which belongs to which? So it turns out Apple stores this in a dedicated GUID inside the EFI capsule file or bundle, whatever you want to call that, and it looks for a header in the GUID, finds just the 16-byte identifier, and pulls that out. Then it grabs the board ID of the Mac it's running on using the I/O registry API, compares the two, and says, "All right, this is a match. This is the one this is the physical file that we need to use." So as an example, MacBook Air, MacBook Air 7.1, 7.2. There's two models there, the 11 and the 13-inch. Do they get their own? Do they each get their own, or are they similar enough that they go together? So it turns out in that specific case, if you look at, I don't know if I got it later. Oh, there we go. So here, the EFI version string is that. It looks inside the file, and it finds that GUID again. And it actually lists the model ID, the board ID for both these machines. So it can fold things together, so there's less of a file sprawl to take care of. And this is from the paper. This is a simplified sort of flow chart of how it decides to pick what updater file for a specific model that it is running on. Let's see here.
It's me.
This is Rich.
So, a lot about EFI. The word EFI probably said 200 times already. So that's all the background. Hopefully you're all fully up to speed with everything that's ever happened in EFI, everything that Apple has ever done with EFI, and every security vulnerability that's ever been found in EFI. So we're good. So what's the new work? What were our research questions? Before we go into some research, we want to have some questions to answer. So what were the things that we actually wanted to find out? As I said at the start, one of our main interests was trying to measure how well EFI security support was being serviced by vendors as compared to their software security support. Is it on par? Is it lagging behind? We also wanted to see were all Macs being treated equally? If you had a 15-inch MacBook and a 13-inch MacBook, would they both receive EFI updates or only one of them? What about the different OS versions? Apple supports supposedly the last 3 versions. So up until a few days ago, that was 10.12, 10.11, and 10.10. Are they all treated equally with respect to EFI updates? Obviously, we wanted to see how well the real world compared to the ideal world. What was actually out there compared to what Apple wanted to be out there? How well were these EFI updates getting automatically installed with the larger OS and security updates? And then, a lot around the visibility to EFI, what are users and admins actually told? So, some of the common update issues that we're thinking about, do the EFI updates just work? They are squashed inside these OS updates, and they're pretty invisible to the user. They happen in the background. No one really knows that they're executing. Do they work as intended? Are all of the supported OSs that are receiving security patches also receiving EFI patches? Does the real world match? And how easy is it for people that have bought Apple equipment to actually find out what state their EFI is in? So the analysis, how did we get some answers to this? So there's really 2 phases to the analysis that we did, and I'm going to walk through both of them. So the first one was we were building up a picture of what Apple had released. And like I say, we went back through 3 years of OS and security updates from Apple. And at the time, this is 10.10, 10.11, 10.12. We extracted all of the EFI firmware updates that were bundled within them. And then we built its data set of triplicates. And the triplicate data set that we built really relied around the OS build number. So what is the version of the OS that the update is getting the system into? What is the Mac model or board ID? Pepijn explained kind of Mac models can cover many different board IDs, so we grabbed both. And then obviously the specific version of EFI that was related to that board ID for that OS number. So it can get a little bit complicated, so we've got some examples here. So these are kind of the more common numbers that you would expect to see. OS build number, 16G29, a Mac model, that's an iMac 15,1, that's its board ID, and for that particular build version of the OS, the particular EFI version that was released for it was that long number, IM 1510207B29. And so these relate to the build number is 10.12.6. That's more common. People kind of understand that better. The board ID is an iMac 27-inch 5K late 2014, and then that EFI string just means version 0207 build 29 of the EFI. So we extracted all of these out from the firmware, from the OS updates, and built them out into a big fat table. This is kind of a slice from one of the many tables, big tables, lots of numbers, and we were then able to correlate specific versions of Mac hardware to specific builds. So we obviously had huge tables of data that allowed us to do this. And the analysis that we did here was nothing about comparing it to the real world. This was just looking at what Apple had released. Were there discrepancies in there? Were there anything that was in there that looked weird? Spoiler alert, yes, there was a lot of things that looked weird, and we're going to talk a little bit about them. But these kind of questions, which models of Mac were seeing updates and weren't seeing updates? Were there missing EFI updates in particular circumstances? Were there differences between the EFI updates that 10.10, 10.11, 10.12 were receiving? And we also looked for weird anomalies in the versions of EFI. We found some strange things where the Apple the Apple EFI build system seems to kind of be flipping endianness on the version strings for some versions of EFI. Just randomly, sometimes it will be big endian, sometimes it will be little endian. No explanation. So phase two. Phase two is when we start to take this real-world data. So we got 73,000 or over 73,000 samples from real-world systems, real-world Mac systems that were being used in production. Again, we extracted just three of those same three versions from it. The OS build version, the specific Mac model, and then the EFI version. So now we could build up a data set that was comparative to the one that we'd been built up based off the OS updates, and look at the difference between the two and see what it told us. Now, important to know is while we sampled 73,000 Macs, only 54,000 of them actually were running 10.10, 10.11, or 10.12. Anything that wasn't running one of these main OS versions, we just dropped from our data set. There's no point us analyzing, is Apple still supporting EFI when they've stopped supporting that software? If you're still running 10.9 or below, you've got much bigger problems than someone compromising your EFI. What this allowed us to do was to predict what EFI version any system should be running given its hardware version and its OS version. And then with that prediction that we built up from the OS versions, we could see whether that mapped to reality of the real-world data. This is a big thing that you're not going to be able to read the details of. It is in the paper. The point being, when we were starting to look at these big data sets, we started to use kind of a variety of visualization techniques to see anomalies more easily because it was just fields and fields of numbers otherwise. So we kind of stared at the screen for a long time. The interesting things on this one are the yellow blobs, but there's some other patterns in there that were quite interesting as well. So what was it that we actually found?
So given that idealized data set that we now had and where we could see some drop in support already, we went to our data that we gathered from folks out in the field and kind of tried to figure out, so how does that match what we know to be at least the model of truth? So we found a number of things here that stood out. So there's definitely real-world systems that are out of date. They also, the security updates gradually drop what models they actually support. The quiet failure is pretty clear because when we asked folks that gave us the data, are you aware that X% of these models out of date, they had no idea and they really had no way of telling that either. And then there were some unexplained EFI update regressions that we'll get to into as well that seem to be one-offs. the real world data. So here, sampling of people that have given us data. I didn't put the organizations they're with on there because I didn't want to get them in trouble, but I did want to get a chance to thank them. So thank all these folks for giving us larger, smaller, whatever it was. We anonymized it all and ran over their data. Lots of verticals. There's tech, there's higher ed, there's small business, there's some foreign data sets as well. So we really tried to get a good representative set of the real world. So the message here is that a successful OS update does not mean you got a successful firmware update, which is an important point to remember, because when you install one of these and your machine is now at minor version +1, you'll just assume, well, we're good, and everyone tells me to stay up to date, so we're good, we're safe. Turns out that's not the case. So we went in and basically said, with given a Model X, a Mac Model X with OS version Y, does it have an EFI version that is older than it should be? So specifically at older. We didn't look at ones that were newer because they may have gotten an update and then were loaded back with an older version of the OS. We specifically wanted to see version, model, EFI older than it should be according to our data set. And once everything flushed out, 4.2% of that total data set was running an EFI version that was older than they should be. This is across 10.10, 10.11, 10.12, so 3 OS versions. And then there's some outliers, like a model that apparently had huge number of models out of date was the iMac 21-inch late 2015. That had up to, or specifically, 42.9% of models that were out of date. And then the highest overall OS deviancy per major OS version was 10.12, and this number actually went up. So 10.10 was the lowest, and then 10.11, 10.12, it slowly inched up to being more out of date. Interesting data point. We couldn't, in the end, fully figure out why that was, but it seemed to be creeping up for some reason. And here you see this as well. Flipped around, actually. It got better, then it got worse. And this is this is an example of sort of the top. This whole list is in the paper, so you can go nuts and check out all these and see which ones you have in your org, and if you should be concerned. But if it's in the top, probably more concerned. So this is a list of machines that were out of date by top numbers. So iMac 16,2, and as you can kind of tell, there were some really late models that really hit high in the out of date count. You can be software secure, but firmware vulnerable. Point we made before, and we'll make it again. So, does that supported OS? And this is a vague term that Apple doesn't really spell out anywhere. When asked, they will tell you just run the latest, and you'll be secure. But they have sort of a soft policy saying we'll support current -2. So they'll, at the time we wrote this, 10.12, 10.11, 10.10, got some form of security updates, which has its own caveats, because they will port some stuff, but not all stuff, depending on whether it's an issue on the OS or not. So only Apple knows what the schedule is, and they can pull the plug at any time. 10.13 just came out, so you can be probably certain that 10.10 will now officially no longer be supported. And if you're still running 10.10, I'll ask you why. And then you might have a good reason, but you really don't want to be running that for a number of other reasons already. So with all of these the versions of the OS that are not the current, they get security updates. The current OS gets OS updates, and they all include the EFI as well. So meaning that if you're not current and you get security updates, EFI at some point will drop off as far as like which models actually get updates here. And then again, the only way to be sure of broadest coverage is to run the current OS. That is really the best. If you need to know a best practice around all of this, run the latest OS, and you'll have the best shot at being up to date. As an example, this is from the most recent before 10.13 came out. When 10.12.6 was released, El Capitan and Yosemite also got their own security updates, 2017 003, the third update of 2017. 10.12, the then current OS, contained 43 EFI bundles. 10.11, 31. 10.10 had 1. So there was 1 update. that is not how the support for those OSs flushes out. There are many more models that support those OSs. This drops off. And let's see, is this you, Rich?
I think so.
There you go.
So, patch for one doesn't mean a patch for all. Obviously, all patches aren't equal. Some of the EFI updates have nothing to do with security at all. Maybe it's just fixing a non-security bug. And we realized that, so we wanted to dig in on some of the CVEs that Apple had publicized as fixing in their release notes. The CVEs that we particularly jumped into were some of these ones that came from the research that we pointed to earlier. So Thunderstrike 1, Thunderstrike 2, the last two CVEs don't have a fancy name, but they're from the research that we were pointing to earlier. And all of these CVEs are cited within Apple's update notes as being fixed. You know, if you install version X of their OS update or security update, then your EFI will be fixed against these vulnerabilities. And so we wanted to see which models were actually receiving EFI updates in the OS updates that cited that they were fixing these vulnerabilities. And so these are the numbers. So these numbers here are the models of Mac, the specific models that were released by Apple that never received an EFI update to address these vulnerabilities that that was claimed in the release notes were being addressed. So Thunderstrike 1, there were 47 models of Mac that never received an EFI update in that patch set. Thunderstrike 2, 31, CVE 2015, 7035, 25, and CVE 2016, 7585, and that's all Frisks 22. So these numbers are kind of strange and worrying. You know, if Apple is releasing CVEs saying that they're addressing them, but they're only addressing a subset of the models that can still run the software update, people are going to be getting this false sense of security. They will think that they're patched against these particular CVEs, when in reality, depending on their model of hardware, they might not be. The visibility to that, are they getting a patch or are they not, there really isn't any to an end user. You've got to do the kind of analysis that we did to extract firmware updates and then correlate them across all of these different vectors. So some models are EFI orphans. I think this is Pepijn.
Yeah, there's also what we dubbed orphans, in that they shipped from the factory with a certain version of EFI, and we kind of tell whether they're new by the actual build. So if they're in the low single digits, B01, B02, those shipped from the factory after that never got a field upgrade to their EFI. So folks may think like, well, these are pretty new, it should be okay, but other models after they were released got updates, these never did. And this is sort of a breakdown of between the two statistics. So there are models that not receive any updates because they're old or otherwise Apple made a decision not to do that. 16 specific models in our data set do not get any EFI updates. And then there's 18 that have sort of those factory EFIs that at one point shipped, but more recently and never got an update. This is from the paper, a snippet here where you can kind of see how that breaks down what we talk about when we say factory build. So those are all, you can see low single digits, and they may be were seen in the field with newer versions, but we never saw those actually in what Apple shipped. So again, there is, there seems to be various streams of do these get updates or not going on, and there's not one single story here. So as far as silent updates goes, so Apple made the decision to make these updates silent, which is a good thing because folks definitely don't need to be bothered by this. The problem is only that if it's really silent, it's kind of the tree in the forest if no one's around. Well, it turns out if an EFI in the forest doesn't succeed, it also does not make a sound. It gets one shot, like I said. There's no retry other than reinstalling the OS or the security update, and there's no logging or notification or anything. So there's nothing to the user. There's nothing an admin who manages many Macs in their organization could go back to and find out. And since EFI to a lot of it's definitely home users is a complete unknown, they will not go look for it either. So it goes ignored. So result, as our data set turned out, EFI is often out of date for the version that it is running.
So lots of versions, lots of anomalies in there. One very unexpected anomaly that we found was something that we believe is a QA failure. That's the only way that we can describe it. And this was when Apple just released the wrong firmware in a security update for a significant number of systems. So the very first security update this year for 10.10 and 10.11, it had the name 2017-001, was released in March. For some reason, we believe it's a QA problem, they released all of the firmware packages within these security updates with 2 versions old EFI versions, not updated versions, two versions old. So we can see here for this particular MacBook model, MacBook Pro 11,2, in the security update 2016-002, this was the version string that came out. B17 is the thing that's really important. Then in the next update, it was updated to B18. That's normal. That's expected. And then in the first security update of this year, they released B17 again. That's weird. They shouldn't be releasing old firmware. And they did this for around 47 models or so. The exact numbers in the paper, I can't remember off the top of my head. Now, here again, it's like a long list. It goes way off the bottom of the screen, but just showing that there's all of these consistent. They basically released the firmware update bundle from 2 security updates ago, which raises the interesting question. If somebody updated with that security update, would their firmware have been downgraded? The quick answer is no. You aren't able to downgrade EFI firmware. There's a protection in the pre-boot EFI environment where it doesn't actually allow itself to be downgraded. So that's good. People who had installed those updates didn't regress their firmware, but they certainly didn't move it a step forward. So mitigations. I think we're coming up to the end, so...
Yeah, so what can we do about all of this? Clearly, because it's so quiet, yet pretty important, what can we do about this? I'll go through a couple of things that you can do from a very basic level to get some actual visibility on this. So do some login reporting. I'm sure at this point, logging and reporting is one of those problems we have at least 10,000 solutions for, so we can pick one. You can run these updates out of band too as a mitigation, and then Apple is doing some stuff as well, which is good. So I have here a couple of ways of telling whether or not 1 or 10 or 100 or 1,000 systems that may be under your supervision are out of date. So OS Query is a great tool. If you don't know about it, osquery.io, go check it out. But it can very easily, it uses SQL to basically query system status and system information. You can grab that with the statement there. Puppet can do it. Chef can do it. You can even fire a shell script if you want to do that. Apple System Profiler gives you that info as well. A good first step. Fire it off if you manage a couple of Macs or even your own to see where it's at. And given some of the data that we're releasing, you will actually be able to tell whether or not you're good or not. Then once you know which systems are out of date, you can simply reapply the current OS or security update. It doesn't have any negative effect, but it essentially gives you the ability to give the EFI update another shot. You can also use EFI Updater by itself. We give the way to run that in the paper as well. So applying them out of band, like I said, if you do this, it doesn't harm anything. You can just reapply it. It will mostly give the EFI update another chance to run. If you do an OS updater, use a combo updater, sort of best practice. It's a little larger, but you have less chance of anything going wrong. And then if you do a security update, they're always delta, so just apply to one that it should have gotten. And it requires a reboot, so set user expectations, of course. Make sure that they understand that this is important stuff. Apple is making changes, just in case everyone wondered, does Apple know about this and do they care? They definitely care. So in 10.13, they are releasing a tool called EFI Check. It doesn't actually do anything for updating yet. It is purely an integrity check. So it basically looks for EFI that has been altered somehow because they were vulnerable, and one of these exploits that we talked about were applied or ones we don't know about. That is to say, Apple is not ignoring this. They want to get more data, but obviously they need to also jump through all sorts of hoops of privacy and security and all of that. So this is what they came up with. One of the developers on the firmware team recently had gave some insight into that as well. And this dialogue here, I have to say the user experience isn't the greatest yet. It is pretty anonymous and pretty unclear exactly what the potential problem might be. Hopefully they will work on this and make this a little more descriptive. But we're happy that Apple is taking this seriously and not just sort of letting this slide. So EFI integrity checking is now a thing in 10.13. It checks once a week to see if your version is not on their whitelist. And if it's not, it will show you. And I would say that if you do see this, do Apple a favor and send them the report, because they really need everyone's help to improve their data set.
So, coming right up to the end, a lot of what we spoke about is how difficult it is for users and admins to actually see what's going on at the EFI layer in their system. So we've built some tools and APIs to help with this. We've called it Effigy. And the whole point is just to try and kind of help people see what versions of EFI that they're running, and is it the expected version. So we've kind of, all of that data that we gathered, we can now use and we're making available as an API so that people can check against their systems. We have got a very quick demo. It's just text on a screen, so it's not necessarily the most exciting, but we'll roll with it. So this is a server that's running. I'm just running it localhost so that we don't have any network problems. But the Effigy server is running local. And we're going to run two times through it. The first one is actually going to be taking the data from my laptop here, which is hopefully all up to date on the 10.12 branch. So we're going to run it and see the output. So first, we can see the data that's been grabbed by the system. A hash system UUID, this is so that we can track uniqueness, but it's pseudonymous. Hardware version, this is the EFI version here, SMC version, board ID, OS version, build number. So we do want to submit this because we want to get some answers, so we'll press yes. Submit that up, and then the API kicks us back that we're running above 10.10, that's good. 10.10's not really receiving EFI updates anymore. We're running the highest build number, we're running the latest branch of the OS, and most importantly, the EFI version here, 0226B25, is the one that system on this OS version should be running. So I've got a mock-up of a different system showing bad data, so we can see what it looks like when things are bad. So we can see here now my system is pretending to be a Mac Mini 7.1 running 10.10.4. Other relevant version strings here. We're going to submit it again. Now we're seeing the feedback comes back differently. It's worried that we're running on 10.10. We're not running the highest build number. We're not running the latest OS branch, and our EFI version is not what's expected. We're running B01 rather than B03. It's really this bottom thing which is the most important, like allowing people to have access to this data to be able to correlate, are they running the correct EFI version for their OS? Just a quick look into on the server side. We can see here kind of the data that gets sent up. It's just like it's a single post request. It's a very simple API. All of basically that data that you saw in the list just gets pushed up, and then the response comes back down. So, conclusions. There's a number of different things that we learned from this research and a number of different things that we're going to continue to explore. I think the biggest takeaway for me is around the transparency or lack thereof. Vendors really aren't very good at saying what they're doing at those lower levels of the system. And if you're an administrator, and certainly an administrator that's running in a higher sensitivity environment, the details are really important. You could be in a situation where you've got everything software secure and you feel that your environment is suitably secure, but it could be undermined by out-of-date firmware. If vendors are more clear with the versions that they are and aren't patching, people can make more informed risk decisions. Not all hardware may be treated equally. It's a good thing for people to think. It's an easy mistake for them to make that all of their Mac fleet is going to be treated the same because it's a Mac. Obviously, our data shows that that isn't the case. As we already know, QA is hard. Apple is not above making mistakes like everybody else. And in many ways, like EFI is really like a mini operating system. It's modular. It's built on modern system architecture designs. And given the layer that it runs at, it affects everything running above it. You need to keep it up to date. You need to take it as seriously as you would your OS security. And for vendors, we really encourage them that they provide notifications to users and alerts to users when their version of EFI is not running the expected version. And like we say again, we believe that Apple is taking EFI security seriously. They're continuing to lead the way here, and we're excited to see what they're doing in future because we know they've got a great team there, so we're interested to see how they're going to continue. And yep, these are the links for the paper. So I think that's everything. I'll leave the links up so that people can grab them if they want. And yeah, I think that's all we've got to say. Thank you for listening.
Thanks, everyone.